Are you tired of current energy options? Are you excited for something new? New zero-carbon energy could arise, supplying cheap and carbon-free energy. It could be in the form of nuclear fusion or thorium. In the last century, there has been progress in nuclear fusion, but not enough to be economically viable. However, if fusion did become viable, it would drastically change the energy market. With a huge breakthrough in new zero-carbon energy, how much do you think carbon levels would go down? Take a guess. Well, the answer is surprisingly little. Only a 0.2 degrees Celsius change. Why so little? Well, it's because new zero-carbon energy competes with renewables and nuclear. Also, on its own, it does not stop other non-electric uses of energy, such as oil and gas in cars, engines, and heating. This is why it's useful to couple new zero-carbon energy with electrification. When you couple it, the greenhouse gas emissions go down a lot more. The reason new zero-carbon energy would revolutionize the energy sector is because it would be so cheap. It will become cheaper than all other forms of energy for electricity production. As you can see, it's the orange line here. How does it become so cheap? Because it's a reinforcing loop. Because it's so cheap, there will be high demand. The high demand will drive research and make manufacturing more efficient, which will make the energy even cheaper, which will drive up demand. Now, why hasn't thorium, just taking a look at thorium, why hasn't thorium happened? Why hasn't that become a widely used energy source? Well, it's because of a little bit of history. It's for a number of reasons, but one reason is because of the Cold War. The Soviet Union and the United States had a choice whether or not to use uranium or thorium, right? Whether or not to research those elements. And they chose to research uranium, not because it's better for energy, in fact it's worse, but because it can be used to fuel nuclear weapons. Its byproducts can, such as plutonium. Now, thorium doesn't have these byproducts that can be used as much. It's harder to make a bomb out of thorium's byproducts, which means that it's safer. And now, while that seems like a good thing, because it is a good thing, it means that governments are less interested in funding it because of their alternative motives. So as a result, we researched a lot more in uranium, and because of that, we made infrastructure. And since we got to know the element, the atom better, we made nuclear reactors out of it. And as a result, we've stuck to uranium over thorium. Again, another reinforcing loop. We have an institution based on uranium. Therefore, we're going to implement uranium nuclear reactors, which is going to mean we're going to research more, and it's just going to be more and more ingrained. Uranium, uranium, uranium. I would like to make a tribute to one of my personal heroes, Alvin Weinberg. He was a thorium advocate who, in the early days of nuclear energy, who was kicked out of the Oak Ridge National Laboratory for continually advocating for safety measures and molten salt reactors. He stood up for what he believed, risking his own career, and he was right. So what do you think? Is it worth pouring money into finding a revolutionary new zero-carbon energy source? Or should we use it to invest in what we already know works, renewables and nuclear? It's up to you.